So to start, what is the cloud? I mean, basically, if you ask people, you get a million answers. The reality is we're at the point where it's everything. It's infrastructure as a service, it's bare metal as a service, it's platform as a service. I've seen literally the phrase IT as a service, enterprise as a service, data center as a service. Basically, everything is doing it as a service. And one of the biggest things here is that, especially from a revenue perspective, the accountants love it because you're only paying for what you're using. It's not a capital expenditure anymore, it's an operational expenditure. So from a tax perspective, the cloud is quite attractive. And then from the provider's side, you're getting into the recurring revenue rather than just selling somebody a software package like an email server package or whatever. You're charging them per email. So from a provider's point of view, you're getting that recurring revenue as usage goes. So it's really attractive to them. Which leads into the open hybrid cloud. So the reality is people, originally about 3-4 years ago, everybody was talking about open, like public clouds, and then private clouds being in-house, being the way to go. And what we're finding is, overwhelmingly, is people want the best of both worlds, right? You want to have your internal IT cloud for sensitive workloads or like baseline workloads, like say, research and development or whatever. And then you also quite often want to have access to a public cloud so that you can burst up. So for example, you want to do a big data test and you need 1,000 servers to see if it'll work or not on your data set. To do that in-house on your own private cloud, you may not have the resources. You can fire it up on Amazon for like $2 an hour per server. The other benefit, of course, is in building an open hybrid cloud, you're forcing yourself to go away from vendor lock-in, right? Because, for example, if your product will run on Rev and VMware and Amazon Web Services, if one of those vendors goes crazy or raises their rates or something, you're not out in the cold. Traditionally, we've had, you buy an application, it only runs on some version of Unix or whatever, and then that Unix vendor raises their prices or drops support or something, and you're just out in the cold. So by going with the open hybrid, it's just, long-term, it's going to prevent a lot of pain. It is definitely a lot more work up front than building something specific to a single product. But at this point, I don't think it's a done deal pretty much. And then the other thing is too is, I'm guessing you guys have probably more than just Red Hat Enterprise Linux, right? I'm guessing a few of you may have a few Windows machines, old Unix machines, mainframes, heck, there's still OS/2 out there running stuff. So the reality is you don't want to build a cloud as an additional, thing in your IT department. Ultimately, you want to start consolidating stuff a bit. So with the open hybrid cloud, again, you don't want to have a Linux cloud, a Windows cloud, a mainframe, and then like your traditional IT services. It'd be much better to have it all sort of merged together. And so this is the open hybrid cloud, and of course that's something Red Hat really strongly and firmly believes in. So this has led, so in the past, we've basically, you've got stuff that you can't turn off. You've got your accounting system, you've got your, whatever it is you have that you have to run. And if you can't integrate it with this new cloud you're building, you're going to end up with multiple IT systems and just a real mess. And I'm starting to see that with certain vendors' products where they're not willing to extend them to talk to this or to talk to that other old thing. And that's, of course, one of the advantages in us being open source is, even if we don't, you can extend it. And then there's also the future. Self-service is a huge deal. We're talking about developers going from a model where they have to fill out paperwork and make requests to get 2 servers to 60 seconds in OpenShift, click, click, and they've got, their development instances up and running. And obviously that is saving a huge amount of time and effort and paperwork. And again, rapid deployment of heterogeneous systems. I'm guessing at least half of you, probably all of you, have systems that are more than just Red Hat Enterprise Linux. They're running bits on Windows, there's bits from a mainframe, there's bits from maybe data acquisition. And again, if your cloud deployment doesn't really talk to all that stuff, you're going to end up with sort of a cloud system that is also having to deal with all, it can't talk to this other stuff, and for you to bridge that gap manually is going to be quite painful. And then there's new methods and modes of operations we haven't even thought of yet. This whole cloud thing reminds me of the internet back in 95 to 98, where 90% of the stuff we built was garbage and got thrown out the window. 9% was pretty good, and then there was the 1% like Apache, which ended up ruling the world, the whole web services thing. So honestly, the way we're doing cloud now, in 5 years, we're probably going to look back and just be horrified at what we did and how immature and how terrible it was, compared to what we're doing in 5 years. And so yeah, like I said, I have no idea what people are going to find. So again, that extensibility with the open hybrid cloud, I mean, if you're locked into a vendor and you want to use some other vendor stuff because they've got, something new that's amazing, like the next email or the next web or whatever it is, you need to be able to use that, otherwise you're going to be at a huge disadvantage. And then this leads to a model, what we've seen of hybrid IT. So you've got your mature IT, your payroll, your whatever, your research and development, and then you've got this new stuff like mobile applications, social network applications, various marketing campaigns using new technology. And increasingly, I see these companies with sort of two IT shops. They've got the guys doing the mature, boring, sort of stable stuff, and they've got the guys doing the bleeding edge. And it's expensive to sort of maintain them separately. And ideally with the cloud, you can at least provide them a single set of infrastructure that they can both use. I mean, because if you don't, then you end up with two IT shops, and that's just, well, it's expensive. And certain things too, like say big data projects. I mean, if you want to do a big data test, it requires 1,000 servers. To requisition 1,000 servers, it's going to take probably most of you at least a few days or weeks or maybe even months, assuming you have the data center space to put them. Whereas, if you have an open hybrid IT cloud system, you could fire it up on Amazon Web Services and be done in 2 days. So again, there's these huge just strategic advantages to open hybrid cloud and hybrid IT. So the bad news is we can't build security on SAN. So traditionally, we've been able to build really reliable services on pretty unreliable hardware. Like PC hardware is not, you compare it to an IBM S360 or 390, and a PC looks pretty terrible in comparison. So you can build reliable systems using multipathing, transactions, redundancy, but we can't do that with security. Just fundamentally, and perfect example was last week, OpenSSL, right? I don't care how much stuff you put on the server, basically. The problem is it was in the OpenSSL heartbeat, and it was early enough in the protocol negotiation that there's no authentication. In most cases, there was no logging. And so attackers were going and remotely retrieving 64 kilobytes of data. And Revenue Canada got hit, and they actually had to notify the Privacy Commissioner and say, like, we lost 900 social insurance numbers that we know of for sure. And there's literally nothing they could have done to block that. So when we're building the security of these CloudForms systems, it has to be on solid ground, or we're basically up the creek. And the other thing is the cloud is all about operations. I mean, realistically, nobody wants to run accounting package foo version 1.4.2. What they want to do is payroll on Friday, every Friday, reliably and guaranteed. So the good news is, like, we've had virtualization come in over the last 10 years, 12 years, and that's allowed us to decouple from the hardware side, right? Because I remember back in 2000, your application was married to the hardware, and in some cases you could buy like the exact same server, move the application and operating system to it, and it would fail for some reason. Who knows? So with virtualization, we've decoupled from the hardware to a large degree, and with the cloud, it's going to allow us to decouple the operational constraints. So for example, with the cloud, I mean, you can give developer A the ability to run his own images that he creates, and you can give developer B only access to a catalog of existing systems, and you can give developer C, only access to a single image or system. And of course, that's just not possible without this CloudForms and orchestration technology. Building that into existing products, like existing virtualization, is very difficult. So with the cloud, what we really want is, we want and we need flexibility. So in theory, with the cloud, what you can achieve is basically a single Borg-like system of everything. A great example of this is Amazon Web Services, right? They've got this huge blob of IT, that's running everything from, like, I've got a personal little server running Apache WebDAV on it to do calendar synchronization, all the way up to Netflix. And Netflix is now 30% of traffic in Canada during the evenings. And I think the stats are similar in the US. So in theory, if you deploy a cloud and you do it right, you can literally have a single manageable thing that will do bare metal hardware, infrastructure as a service, platform as a service. It'll talk to other platforms as services and infrastructure as a services, like, say, Amazon or Salesforce or whoever, HP, IBM, Oracle, even all the way up to tying it into existing, application level things. Like, for example, you might tie into, for example, SendGrid to handle all your outgoing email for, like, your entire infrastructure. And of course, this is going to require really strong controls. I mean, you're going to have everything from, like, top secret workloads or research and development patent application workloads, all the way down to, some QE guy running the latest version of the social media app trying to correct spelling bugs or, user interface bugs in it on the same hardware in theory. And of course, there's also the operational side. If you've got a single pool of servers, you can utilize it a lot more flexibly. So one thing I'm really impressed with Amazon is, they have 3 pricing models. They have the hourly price, where you're basically guaranteed to get an instance if you pay that price. They've got the spot price, they've got the reserved price, where you can actually then pay in advance, and then you're definitely guaranteed to get the instance when you need it. So you've basically paid for the instance in advance. And then you've got the spot price, which is essentially whatever slack is in the system, they auction off to the highest bidder. So from Amazon's point of view, in theory, I mean, I obviously don't know what their numbers are, but in theory, Amazon has 100% usage of their cloud by the highest paying customer, which is amazing. I mean, and internally, you can do the same thing. You can, for example, if you're using chargebacks, or if you're just saying, like, you can allocate a workload and say, look, accounting, payroll, that's critical. Payroll has to happen every Friday. Give them the resources they need. The research and development guys, let them use whatever slack there is to run their big data testing. You can't do that if you have multiple systems, or you can't do it very easily if you have multiple systems. Sharing that power is going to be difficult. So the good news is we have really strong controls in the Linux world. The first one, I mean, virtualization, we've had about a decade of KVM now. It's been beaten up pretty good. It's pretty secure. And escaping from the hypervisor onto the host system is, I would say, difficult. I mean, after the OpenSSL bug, of course, I would say, it's always possible. But chances are it's hopefully not going to happen anytime soon. And then the other big one for the cloud space, at least, especially in the platforms as a service space, is the SE Linux, the security enhanced Linux. So traditionally, the way we've separated systems is either by physically separating them, and then in virtualization, you had a virtual server that was separated from your other virtual servers. But with platforms as a service, and for example, Docker, you're running on the same kernel. You're running within the same user space of a system. So you need something to separate those applications out, and that's where SE Linux comes in. And so we've had it for over a decade, and it's been beaten up pretty severely. And one of the best things is OpenShift Online, our platform as a service thing, you only need a valid email address to sign up for it. So people sign up and attack it all the time because they want to get free compute resources to do all sorts of bad things. Everything from Bitcoin mining to attacking other systems. We've seen all number of scammers and scanners. Like the number of people trying to abuse OpenShift, and some of the attacks they come up with are actually really creative, and it's stuff we've never seen before. And we've actually had things blocked by our SE Linux policy that were 0 days. So, for example, one attacker was what was he doing? Oh yeah, he was trying to talk to the TUN device, the tunneling device, to set up VPNs and stuff, to basically hide his traffic. And in a normal system, the user's sort of allowed to do it a little bit, But luckily with our SE Linux policy, that was blocked. So we didn't have this, all this encrypted traffic flying around that would have probably been very malicious. And of course, we've got IP tables, the firewalling, which again, we've had it for over a decade. And again, I'd like to say there's probably no major bugs in it, but no guarantees anymore after what we saw with the OpenSSL flaw. So yeah, as I said, the OpenShift Online, I love it because it's a perfect tethered goat. Like I've attacked it and annoyed the heck out of them. I once generated 36,000 alerts in 15 minutes by doing something naughty. And so it allows us to see real world attacks, whereas in past, we would have built the software, we would have done our best to make it bug free, we would have shipped it to you guys, and then you guys would have gone, oh, hey, we got attacked and we're up to date, so what's the story here? And do some forensics and then, we find a new bug or something. So that model's changing now, as we're actually seeing this stuff ourselves, and we're able to get to it a lot faster, obviously. So the other thing is, you need to be able to dial the security up and down. Like one size does not fit all in the cloud world. I mean, if you're going to have a single cloud for everybody, you literally need to be able to handle whatever security level those people need. Some of those workloads are going to be highly regulated. If you're in healthcare or insurance or you're doing government contracts, data has to be encrypted at rest, or data has to be encrypted in transit, or data must reside within the United States of America. There's also going to be contractual requirements, and I can't even begin to imagine what lawyers are writing into these things now, when they find out that a workload is going onto a cloud. So obvious one would be, you can do your workload on your internal cloud, but you can never send it to a public cloud. And there's also going to be the issue of multiple legal jurisdictions. If you're a large company, or even a multinational firm, and you have an internal cloud, and you have workloads moving around dynamically, if you have a workload from Europe and it gets moved to the US, that might be illegal, depending on what that workload is. And then the other thing is, you're going to have systems all over the place, some that are maybe in use for years at a time, like your accounting and payroll, and then you're also going to have some QA guy spinning up an instance for 5 minutes so he can test a user interface bug and then turning it off. So whatever system you use will have to service everybody, or else they're just not going to be able to get their job done. And so the whole point of having a cloud is kind of moot if you can't get your work done. So that means we need to do secure deployment and updates. You can't deploy insecure systems and patch them in the field in all cases. I mean, for example, in a private cloud, you might be able to do that, but in a public cloud, you may not be able to do that safely. And the perfect example of that is the OpenSSL bug. I mean, that was not only affects the servers providing OpenSSL, but any OpenSSL client, in theory, is vulnerable to attack. And so that means yum update. It runs over SSL. So in theory, some attacker could use that to snarf some data off your server. Luckily, it wouldn't be a lot, because yum would only connect out a few times before it gives up. The other thing is, if you're paying by the minute, you don't want to deploy a system and then run yum update and wait 5 minutes for it to go, especially if you're only planning to use that system for a few minutes to do a QA test or something. You've just doubled your costs in what you're paying. You also need to keep the systems up to date once they've been deployed. And then you also need to properly configure them. So there are configuration changes you may need to make in the field. And in some cases, you may redeploy new systems. In other cases, it'll be a lot faster to just, okay, let's change this setting on all these machines, click done. And then the other dirty secret is you're probably going to have to be able to deploy insecure systems. So, I mean, coming from the security side, we do this all the time, where we have to run software with known vulnerabilities to test it. Even like with the OpenSSL thing, I've still got a whole bunch of test machines running OpenSSL vulnerable versions so that I can test, the various exploit codes that come out and see, is it worse than the last one? Or, what's this attack signature for this? And especially for development and testing people, they're going to need to be able to say, look, I need to install this old version of the software that's like 5 years out of date and completely insecure, and I need a waiver for that. So you can't have, like, say, a blanket policy that says all systems must be up to date, because you're basically going to make life impossible for a large segment of your population. And then there's the orchestration and management piece. So we need orchestration because you're you may have Red Hat Enterprise Virtualization, you may have VMware, you may be using Amazon Web Services, you may be using Microsoft Hyper-V, you may be using all of them. You need something that'll talk to all these systems and allow you to manage it as a single entity, because otherwise, you know, you're going to have two sets of everything or more. And this is especially true for self-service clouds where, you know, you might want to give one, like internally at Red Hat, for example, I have on the one cloud I have access to, what is it, about 1/4 terabyte of RAM. I forget how many CPUs, I think 200 gigabytes of total online disk space, and there's no restrictions on bandwidth for me. Other developers, you know, will have less or more resources. You're also going to need things like controlled access to the images. So for example, traditionally we've used physical security, or in the virtual machine world, you know, it's only certain people can have access to that virtual machine. With the cloud world, if you have, for example, a machine image, it might come with default credentials to a database, or it might hold data on employees. And so you obviously can't have the intern spinning up a copy of that and then copying the data off of it. So you need some really tight and sophisticated levels of controls, because on the one hand, you might need to let developers, you know, spin up and work with like an older copy or even with a live copy of the data. Because you know, sometimes there's just, you have to test what you're testing. You can't test like a replica of it. So you're going to need to support these multiple operation models of, you know, some people being given full self-serve access, like, you know, SRT. We can spin up anything we want. It can be out of date. It can be insecure. All the way to, say, the production guys where, you know, you're going to say things like, no, it has to be up to date. It has to be secure. You can't install OpenSSL 1.01 anymore unless it's been patched for, you know, the OpenSSL bug. And if you don't support that, again, it's just, you're basically going to build a cloud that just makes people, you know, very frustrated. So falling into that now, we've got a couple of cloud security standards and technologies. So the first thing is we've got a whole bunch of existing security standards like PCI DSS that have been forced to move into the cloud because so many people have moved workloads into the cloud that, you know, they had to basically give either, you know, allow compensating controls or give a waiver, or, you know, some version of that's allowed to happen. Otherwise people just, well, they would have done it anyways. Some of these standards you're going to have to legally support. You know, if you're in Europe, there's certain privacy regulations. If you're in the US and you do healthcare, there's HIPAA. If you're a financial firm, there's, you know, Sarbanes-Oxley, and that other one I forget the name of. And you're also going to be judged by these standards, especially if you're a provider or if your partners want to work with you. So I'm already seeing things where, you know, people are sending out requests for quotes and saying, we also want your response on, say, this security standard. You know, either we legally require the security standard, or it's not required, but we really want it. And, you know, if provider A can do it and provider B can't, that's going to put provider A in a much better light. So that leads to the problem of providers, you know, they want to minimize the number of standards they're adhering to. A great example of this is Amazon Web Services, right? There's no way that they're ever going to allow customers to audit their infrastructure. You know, it would be 10,000 audits later. It would be hugely disruptive and costly. And so I'll get into that actually with FedRAMP a bit. And then the other thing is, people who come up with their own standards, that's going to be a tough sell. And the other thing is, coming up with good standards is actually surprisingly hard. So what we're seeing is a lot of people either use the standards they legally have to, or they adopt those standards, or they'll adopt them and then modify them as needed because they may have some internal business process that requires something, or, you know, they also do business in Germany, so they kind of have to modify it a bit to be compliant with German law or whatever. But the good news is there's basically 3 sets of standards you're going to have to worry about. So the first one is FedRAMP, and in my opinion, this is definitely, it's one of the best security standards I've ever seen. They've learned a lot from the past. So they've done things like, it's all based on open, like non-patented, free standards, like the common products and enumeration stuff, the common vulnerabilities and exposures, the common weaknesses database. the OVAL, basically a whole list of acronym soup, all of which are open. The standards are all out there. There's numerous products that implement them. And it also addresses the many providers to many customers issue. So, if you have 100 providers and 100 customers, that is in theory, 10,000 different audit relationships. So what FedRAMP has done has said basically, you certify to a certain FedRAMP level. So for example, something good enough to run top secret workloads. And then a government agency goes and gets what's called an authorization to operate. So they basically say, hey, our workload is top secret. We found Amazon Web Services, they support top secret. Can we get an authorization to operate? And this entity in the middle says, well, yeah, we've confirmed their FedRAMP certification. Yes, you can get your authorization to operate and you can go run your workload there. So the beauty is, it's third-party testing laboratories, which in theory will keep people more honest than any self-certification. And so as a private company, obviously you wouldn't be getting an authorization to operate, but you can basically show them the FedRAMP standard and say, can you please show me which of these boxes we can take off and are covered. It's, like I said, it's flexible. It's supported by a lot of tools already. I mean, we've got OpenSCAP, which we've had for a couple of years now, in Red Hat, which supports Red Hat Enterprise Linux and Fedora. And the other biggest thing is it supports the continuous testing and certification. So the biggest thing I've always seen traditionally with certification is they've always traditionally been point in time. Like, yes, as of Saturday at noon, we finished the audit, you passed it, everything was good. Don't change the system at all. Well, that's not going to happen anymore, especially with something as big as, like an Amazon Web Services type entity. I mean, they're adding new services every month. They're changing stuff, they're updating stuff. So it's this ongoing continuous certification process, which is really critical, especially in the cloud, because we're literally still making this up. Like we've just discovered, that everybody wants to merge everything together. Okay, we're going to do that and support that. Docker. I saw Docker 6 months ago and thought, hey, this is kind of cool. I should keep an eye on it because Red Hat will probably be interested in it. And then all of a sudden, it's like, yeah, we're doing Docker like now, not a year from now. And there's providers I've seen that are popping up with new technologies that I couldn't even have imagined. Things as a service that it's like, well, actually, no, I really hate having to run, that particular application or support that, and I can just buy it as a service for $5 per user per year. Heck yeah, I'll do that. So FedRAMP is pretty good. Sorry. And like I said, so Red Hat support for FedRAMP is really pretty solid. The main thing is we've got the OpenSCAP, which is the tool set to scan the system. And we've also, more importantly, got the content. So the content will say things like, RPM has to verify GPG signatures, right? And so there's actually a couple places and things you need to check to ensure that that is totally enabled. Other standards like, say, password length or complexity, or you have to change it every 10 days. So all that content is in there for sort of to the FedRAMP standard, and there's also some of the other common criteria standards as well. The good news is also you can apply this during Kickstart now. You can actually create a Kickstart file for a system that will basically security scan and fix itself during installation. So you will basically never have a system that was vulnerable. There's also automated remediation tools. So the traditional model has been people run the OpenSCAP and then pay an hourly consultant to fix everything, which gets expensive. And a lot of this can be mediated quickly. Sorry, it's the alarm to pick up my son from school. Totally forgot to disable that. So where was I? Yeah, so there's these automated remediation tools that will, for example, ensure that the system is checking GPG signatures on all the RPMs, that system updates are enabled. So we also, Red Hat, we publish a lot of the data. So if you go to, I forget the URL, but if you search for Red Hat Security, like CPE, there's a web page that has links to all these documents. They're basically XML blobs that you can then feed into tools. So like there's OVAL, which is the Open Vulnerability something language. And basically, so that would describe, this product with this version of OpenSSL is vulnerable to, CVE 2014-0160. So taking that OVAL definition file, you could feed it into your security scanner or whatever your compliance product is, and scan your system and find out if it's vulnerable or not. We also published the CV data in machine-readable format, the CP data. We're also putting the CW, so the common weaknesses and exposures is essentially a catalog of like, this is a buffer overflow, this is a buffer underflow, this is a buffer overread, and splitting them all up. And we're actually putting that now in the Bugzilla for the ones that are, I think it's if they score 7 or higher on the CVSS scoring, so that you have a much better idea of what it is you're actually dealing with. Because I've seen 1 or 2 people refer to the OpenSSL thing as a buffer overflow, and I like literally almost had a heart attack. Because I was like, if they found a buffer overflow in OpenSSL that was remotely triggerable, like, I quit. I'm going to go be a plumber. I just can't do this anymore. Like that literally would be the end of the world as we know it. And then the good news is Red Hat, of course, we've got a lot of people in the federal government and security space, and we're pretty heavily involved in this. I mean, we've been selling RHEL to the federal government for a long time, and of course that means we have to do these things, otherwise they just won't buy it. And like I said, I personally really like FedRAMP because it's completely open, it's really well documented, it's actually a really well thought out standard, and it's continuous testing. So that in theory, anytime you make a significant change to the system, you kind of have to recertify a bit to make sure that you haven't done something that's completely mucked it up. So then the next big one is the Cloud Security Alliance. So the Cloud Security Alliance has a couple of standards, and they're really aimed heavily at operational security. So for example, if you read the CCM or the Common Assessment Initiative questionnaire, they'll have questions in there like, for example, like, do you use NTP to synchronize all your servers so that the log files actually make sense when you look at them? So they're very heavily operationally oriented and less sort of technology oriented like FedRAMP is. Currently, the CSA stuff is largely self-attestation, and there is now third-party testing through the BSI, the, I'm blanking on what that acronym, the British Software Institute, or yeah, I think it's the British Software Institute. Anyways, basically the guys that do ISO. And they do provide mappings to other security standards. So like, like NISPOM, FedRAMP, HIPAA, SOX, all those things. And they are currently working on some additional standards and updates. And the biggest thing that'll be happening in the next while is the Cloud Security Alliance is working on third-party assessment and continuous assessment. So again, like FedRAMP, it's not enough to say, like, as of this date, yeah, we were doing all this stuff, it was great, it was wonderful. It's going to move to that continuous assessment model, so anytime you make a change, or even possibly some of them will be actively scanning, and making sure that this provider says they're running software up to date. Okay, let's go actually check and make sure it's running up to date. And those are available at the cloudsecurityalliance.org. And again, Red Hat support for the CSA. Again, a lot of this boils down to OpenSCAP because testing for certain security settings and so on is actually surprisingly difficult. Like to, for example, test, what is a local user's password can be quite difficult if you're using LDAP or Kerberos or something. In some cases, you can't really test it as well as you'd like. So again, OpenSCAP is going to be used pretty heavily on that. And a lot of the stuff the CSA is looking at is actually, like, they will ask things, for example, do your employees have security awareness training? Do they have training on the privacy? Do they have training on the sort of the operational security side? Which I think is good because, again, we can have great technology, but if you put the wrong people in charge of it or people that don't know what they're doing, it's going to be a disaster. So actually, almost exactly 1 year ago, we submitted our Common Assessment Initiative questionnaire for OpenShift Online to the Cloud Security Alliance, which is interesting because actually OpenShift Online runs on top of Amazon Web Services. So some of the questions we're unable to answer in the sense of, like, we don't run, like, we're not responsible for the physical security of these systems. That's effectively outsourced to Amazon. So what happens there is essentially we say, well, we're running on top of this platform, and luckily Amazon has also submitted a cake entry stating that, for example, with physical access controls, obviously, we have locks on the doors and fences and stuff like that. So you're going to see, I think, a lot more of this sort of flow through of security standards with providers because, most of the startups I'm seeing now are not buying hardware. They're running everything on Amazon Web Services to begin with, and then if they maybe get big enough, they're buying their own hardware. We're also a corporate member of the CSA, and we basically keep an eye on, what's going on there. Some of it's moving fast, some of it's moving slow. And like a lot of things, we're seeing, it's slow, 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 and then suddenly, there'll be a significant change. And then your third set of standards is the ISO, of course. Unfortunately here, being that they are quite, what's the phrase I want to use? Large and, I guess, bureaucratic, they're not really planned to be released until late 2015, and that's assuming they're on time. I have no idea internally, what that means, like what their track record is for completing on time. So it's going to be ISO 27017, and they do have initial drafts up. They're not super fun to read, but they are pretty comprehensive. And the reality is once that standard drops, of course, everybody is going to have to start paying attention to it because, well, it's ISO. Unfortunately, like I said, it hasn't finished yet, and it's probably a year and a half away, so we'll see how that turns out. So again, our support of ISO 27017 isn't, I can't really speak to it because the standard doesn't really exist yet. But again, it's going to be OpenSCAP on the technical side. And we are keeping an eye on them. I don't expect any surprises from FedRAMP or from the CSA or from ISO. But there have been occasionally, poorly worded things. Like I remember my favorite thing from PCI DSS is, everybody seems to interpret it that you absolutely must have a virus scanner on every system. And of course, you guys are all kind of like, well, we're running RHEL on this machine. Like, we don't want to put a virus scanner on it. That's just, not very applicable. So again, finding like compensating controls or maybe, there's another way to address this fix without it being as messy or as difficult as it needs to be. So that brings us to the non-cloud security standards. So, we've got all the usual suspects, PCI DSS and all those guys. And like I said, they've basically been forced to move to the cloud because all the workload is moved there. And again, you can mostly get away with compensating controls. And then, so a quick note on the failure cases. So one of the big ones, obviously, is the failure to include ongoing testing and certification. Perfect example of that, DigiNotar. I don't know if you remember that Dutch certificate authority that was found to be completely, like they had viruses on their certificate server. Like they were completely wide open. And then, of course, there's been companies that have been certified to various security standards and have had massive data breaches. And it seems like data breaches just are getting absurdly huge. Like I remember when it was tens of thousands of people, and that was like really bad. Now it's tens of millions. And I think we've actually possibly crossed the threshold where every adult in North America has had their personal data leaked at some point. So I suspect one of the outcomes of this is the cloud providers might keep an eye on each other to, basically keep each other honest, and as a competitive advantage, if they can say like, look, cloud provider A has actually fallen behind on this standard, you legally can't have your workload there. I suspect this kind of thing may happen. So the good news is we've got a whole bunch of new stuff coming down the pipe. So one of the biggest things we're seeing is the separation of state and stateless systems. One of the biggest reasons is auto-scaling. If you're auto-scaling systems up and down, doing that with stateful systems is much more difficult. Whereas with a stateless system, yeah, you can fire up 1,000 copies of it, no problem. This has some security implications, obviously. So a stateless system, you can lock it down really heavily, like basically like a web front end that is read-only, basically file system, and is maybe serving data out of a database. The other thing is a stateless system shouldn't really be changing because by definition it is stateless. So if there are any modifications or changes on it, that would indicate that there's maybe been an attack or some sort of operational, mess. Another big one is mutable and immutable systems, and that's a big thing in the Docker space, right? Because the way Docker works is it uses the AUFS file system to do layered files, file systems. And so you've got like your base operating system, maybe your application layer, maybe like your whatever your configuration layer, and then you've got like a read-write layer at the top to actually modify things or write state to. And so then, you know, if, for example, you're using an immutable system that cannot be changed, the way you would have dealt with the OpenSSL issue is you would have essentially rolled a new server and deployed all new servers. So this can have upsides and downsides, because, for example, it might be faster to yum update OpenSSL than it is to deploy a whole new infrastructure. The other thing is DevOps, of course. I mean, DevOps has heavily embraced this idea of mutable and immutable systems. Some places are doing it really well, and some places have done it very poorly. And yeah, like I said, the OpenSSL thing, I mean, it's client, it's server, it's everything. So, you know, like Netflix, for example, I don't know, maybe they just kept it internally and hoped nothing bad happened, or maybe they had to deploy the whole new infrastructure. Again, it's something to keep in mind, because with these events, it can be more painful than it needs to be in various ways. The next thing is short-lived systems. This is something we're seeing increasingly. And something I think we're going to see in the future is basically think XINetD, but at like the container or virtualization level of literally a web request comes in, so you fire up a container in, say, 1/10 of a second. It handles the request, sends the response, and then the container is turned off. There's some technology in development that will enable this. So the biggest two things I think we're going to see are the extremely dense ARM systems, because, you know, we're talking system on a chips running at like between 1 and 5 watts. So you're going to have thousands of cores in a single rack. And the other big one coming up is transactional memory. So basically, that's a fancy way of saying you're going to have flash RAM quantities of memory, like terabytes of memory that are addressable, you know, through DMA and accessible through DMA. So it's, you know, you're going to be able to bring up a virtual machine in hundreds of milliseconds versus, you know, the current tens of seconds. And again, you know, that leads to some potential for, you know, every request gets handled by whatever the latest version of the software is. You know, you're not even spinning up and turning off machines manually anymore. It's completely handled at the request level. Another big thing is software-defined perimeters. So OpenShift Online is a great example. You know, we have hundreds, in some cases thousands of gears, so that's individual user applications running on a single virtual machine. And we've had requests from people saying, hey, I'm being attacked from China, can you please block China? And our response is, no, we can't block China on the server because we can't block it for the other 1,000 people on the server. That is just not going to work. So that's a critical aspect of multi-tenant systems. And then the other thing is, especially for auto-scaling, you're going to want to have an intelligent control plane so that, for example, you spin up a new web front end, and it makes sure the web front end is up to date, and then it adds whatever rules to the firewalls, certificates, you know, so that it can access the database, adds the configuration into the load balancer, and so on. Because otherwise, auto-scaling just isn't going to work. Auto-scaling, by definition, cannot have people involved, like, pretty much at all. It's just too fast and too complicated. Netflix has even gone away from auto-scaling to predictive scaling. I don't know if you saw their blog entry, but they basically take data over the last few days, they smoosh it a bit, and they predict the next 15 minutes of demand and turn servers off and on to meet that demand. And that's going to, I think, become increasingly common, because it's a heck of a way to save money. So in conclusion, I mean, the cloud is happening. Your accounts are going to love it, because it turns everything into operational expenditures rather than capital expenditures, which I'm not an accountant, but I've spoken to them and they get really happy about this. And the fact is, IT is changing more than ever, but it's also staying the same. I mean, I've seen applications running that are now actually about as old as I am. You know, my kids are going to encounter software that's, well, literally, you know, was around when their father was born. And yet at the same time, you know, we're supporting completely new, random, weird things. So we're going to need IT systems that will support something 40 years old and something 5 years from now that we haven't even imagined. The other thing is self-serve. I love self-serve. Like the fact that I can now go onto our internal cloud and fire up 10 or 20 or 50 VMs with like zero paperwork and no hassle is wonderful. It's so much easier. And doing it insecurely will be awful. It will be terrible. There will be just no end of horror if it's done insecurely. Sorry, just keeping on time. Okay, good. So I I'm just going to quickly go through the technical stuff, and then that should hopefully leave us about 10 minutes for Q&A. So on the OpenSCAP side, we've got openscap.org. So it's the tools and the content. So if you go to the OpenSCAP page/download, that'll be the content. And then there's also the Fedora-hosted, the SCAP security guide, which is content for Fedora. The other thing is this entire presentation and a whole bunch of supporting notes will actually be placed online, hopefully this afternoon or evening. And actually, like, I'm missing half the URLs, so I'll get those all in the thing I'm posting later today, and that'll be available online. There's also Aqueduct, which is the automated remediation tool. So, you know, when you run an OpenSCAP test and you get, say, 20 results that you need to fix, like password security isn't set right, you know, updates aren't configured right, whatever, you can sit down and do it manually, and that's trouble-prone and takes a lot of time. Or you can run a tool called Aqueduct, which will just magically fix it all. It's quite nice. So the other cool thing is it's not in the RHEL yet, but if you go to fedora-hosted.org/OSCAP Anaconda add-on, there's an add-on for the Anaconda installer that allows you to create a Kickstart file that can not only include OpenSCAP testing, but can include the OpenSCAP fixes. So you can actually build machine images that are out of the gate, certified to whatever, you know, SCAP, to whatever security controls you need. So you can do password, you know, you can set the password policies, you can set the update policies, you can set, you know, the file system security, you can set the file permissions and all that. It's also, you can use OpenSCAP through Satellite 5, now 5.6, and just do a search for OpenSCAP in RH and Satellite. The actual URL is like, it was like 4 lines long, so I didn't put it in there. But basically from Satellite, you can scan systems using OpenSCAP, so it's actually running on the system. It'll report the results back to Satellite, and you can then, well, do whatever it is you need to do with them. You know, turn the systems off, update them, go tell somebody to fix it, whatever. And of course, so that will allow you to scale. Because especially, you know, I'm guessing most of you have more than a dozen servers. The next thing, Kickstart and Heat. Sorry, I didn't have time to finish the Heat template info, but so there actually is a common criteria Kickstart file floating around from the old RHEL 6.2 that can be updated. And there's a link to the enhancement advisory that has the links to the packages. Sorry, I didn't finish the slide on Heat templates, but Heat templates are basically a way of describing a VM that is then run through a processor so that you can then create a definition file for, say, Red Hat Enterprise Virtualization, or for VMware, or for Amazon Web Services. So you can say, for example, this VM needs, you know, this IP address and this gateway and whatever, whatever, whatever. And of course, that varies significantly by, you know, provider. So CloudForms. So CloudForms is Red Hat's orchestration product. So it allows you to do customization templates. You can use Kickstart, which allows you to build the raw system. Cloud Init, which basically allows you to take a finished image and then set it up for whatever you need in the cloud. So for example, the default gateway, the DNS servers, that kind of settings. It also supports sysprep for Windows, which, you know, allows you to take your Windows and customize the install. And then the cool thing is there's callbacks. So basically, when you use CloudForms to deploy a system using Kickstart, you can have it then run literally anything, scripts, programs, applications from within the Kickstart file, and do a callback to CloudForms. So for example, what you could do is you could use Kickstart plus the Anaconda add-on for SCAP. So you could deploy a system, have it run SCAP, and then have it report those results back to CloudForms so that you could have a policy that says, for example, we've built images and they have to be, when you deploy them, they have to then pass the SCAP test for us to finish the full deployment, which would then allow you to approve or deny them automatically. And CloudForms, of course, has a ton of other controls. Like you can, you know, software has to be up to date, software has to be configured a certain way. But this would allow you to actively say that we have deployed an image, it has been scanned with SCAP, it has passed the SCAP check, and therefore we have allowed it. As opposed to previously you would have said, we've built an image, it's SCAP certified, we tested it 6 months ago, and we deployed it. And then we applied some updates to it, and we're pretty sure it's still okay. And you can also, of course, use Cloud Init to call things like run SCAP and then configure the system to be part of the production network. So again, this is really going to heavily matter with auto-scaling and with the self-serve model. On the software-defined perimeter network side of things, we don't really I guess want to say directly support it because it's kind of, it's at a bit of a higher network level currently. But an example of this is, you have load balancers that are firewalled to only talk to your content delivery network. You have web servers that are firewalled to only talk to the load balancers and, the admin systems and the database or whatever. So effectively, even if an attacker, say, knows the IPs, they can't connect. And this is going to matter a lot with autoscaling because, again, with autoscaling, you might have an autoscaling app that scales internally, and then if it hits really heavy usage, scales to a public cloud. And it may contain sensitive corporate data. So, it might not be enough to say, yeah, we have strong passwords, but to actually say, no, we've actively firewalled it, so only our corporate IPs can talk to it. You're going to worry a lot less. A big part of that is going to be using the software-defined networking also to create private virtual LANs. So yeah. Are there any questions, I guess? Sort of on the technical side or on any of the ideas that have been presented? Sorry?
Well, you're talking about the requirement for, virus scanners, for instance, because there is at least a virus scanner available.
Yes.
But how about the mainframe?
Sorry?
How about the mainframe?
Well, exactly. And there are cases where you actually do want a virus scanner on your Linux box because it's maybe a mail server or a Samba file server. And then, yeah, there's situations where are there even virus scanners for mainframes? I have no idea. So this idea of compensating controls is a big thing, especially because, for example, with Amazon, running our stuff on Amazon, OpenShift Online, we can't fix things. Like when somebody says to us, we would like you to encrypt all the hard drives. Well, we can't do that. We can encrypt the virtual machines, but the underlying hardware, Amazon's not going to let us touch it. We can't guarantee that the physical network is laid out a certain way and only good people are on it. So the biggest thing I think we're going to see is this idea of, the standard says X. Can we meet X by doing Y? And what I'm seeing in the standards is less of sort of a directive, you have to run a virus scanner on every machine. But I think what we're going to see more of and what will make more sense is, like, for example, you have to ensure that content or data is being scanned for viruses and that systems, are not having backdoors installed and that you have some sort of mechanism to detect if there's a backdoor or a virus installed. And it might be a virus scanner, it might be, it might be using Docker with read-only containers. If you have a Docker image that is read-only and cannot be modified, if you can't physically change anything on that image, then maybe you don't need a virus scanner, or maybe you do because stuff lives in memory. So I think compensating controls, we're going to have to get a lot more flexible with this. Because like I said, we're already seeing there's providers running stuff on top of OpenShift that runs on top of Amazon Web Services, and those top level providers at some point are going to get asked security questions, and it's like they don't even control the operating system or anything. So for them to give an answer, they're going to have to rely on us and on Amazon's answers, or they're going to have to find some creative way around it. Yep.
Is there a way in OpenShift to scan for vulnerable libraries? Let's just say structs.
Yes. Oh, very good question. So actually, my coworker Vince is, those pavilions? So the question was scanning for vulnerable software like struts, libraries. So those kind of, there's the escalators and those sort of weird half platforms. There's a demo area there, and there's a product, I forget what, or not a product, a thing we created internally a few months ago called Victims, and it's been renamed, I think, to like the Java security standard. So the problem with Java especially is you have these zip files that contain more Java jar files that contain zip files that contain, 10 or 20 levels deep. And we've seen things like where, you have struts 2 is vulnerable, and it's embedded in something, embedded in something, embedded in something, embedded in something you ship, and maybe it's used, maybe it's not used. So what this Victims thing does is it basically unpacks the jars to the deepest level, creates signatures of the files using a combination of things like it does, I think, MD5, SHA-1. It'll look at the actual file headers and say, because they'll define like this library is called struts2 and it's version 1.0. And then puts that into a database, and then so the ones we know that are vulnerable, we tag as vulnerable. So then you can take an unknown package, shove it through this, it'll unpack it, look at all the files, run the signatures, and say, oh, this file matches this one, and so it's probably vulnerable to whatever those CVs for struts are. It currently supports all the Java stuff. And I know it's going to be extended to Python, Ruby, and a couple other things because it's just, we have, like actually unpacked all the Rails source code once and it was like 60 gigabytes uncompressed with all the images and all the sort of media stripped out. It's massive. With OpenSSL, we had a brief scare last week. Somebody basically said, I have a RHEL 5 box that's scanning as vulnerable to OpenSSL. And we're like, no, that shouldn't be possible because we fixed it. And RHEL 5 is not vulnerable. So we eventually nailed down that they had a load balancer in front of it. But for a brief moment, we were like double checking all the source code and I was reading through all the source code looking for heartbeat and making absolutely sure that there was just no way that that was vulnerable. Double checking it. And that is becoming increasingly common because there's just so much software out there. So yeah, if you go talk to Vince, I can point him out to you later. But yeah, no, so that's something we're increasingly finding because also the developer side is, developers, especially in the Java world, they use Maven and all these tools that pull in dependencies. Same with the Ruby world, Ruby gems import. And so they're pulling in stuff that may be out of date, may be known to be vulnerable, may have been forked and there's a good version and a bad version. And yeah, they need tools that are going to tell them at development time, this is bad or good. And also, once you've deployed it, stuff becomes vulnerable. And figuring that out can be very difficult. Yep. Oh, so sorry. So basically, going back there. So for example, what I've done for the cloud security lines, I run their systems actually. So we've got a content delivery network. We're using Cloudflare. So you talk to Cloudflare to talk to the web server. The load balancers are firewalled, so they only talk to Cloudflare. The web servers are firewalled and actually on a VPC, so they only talk to the load balancer. So there actually is no way to talk to the web servers except through Cloudflare. But of course, I have to administer those web servers somehow. So what I've done is I've got like SSH, machines running SSH with a public IP address, and that's all. There's just that one port open. There's no reverse DNS, so it's basically as anonymous as I can get it. The alternative would be to use a VPN tunnel with them, but honestly, SSHing in is a whole lot easier. So basically, for the CSA, for their web servers, the only exposure is one or two servers running SSH that would be very difficult to identify. And then everything else is funneled through Cloudflare, meaning if you want to attack the servers, you have to go through Cloudflare, through the load balancers to eventually get to the web servers, which means basically it limits attacks to the application surface. It takes away all the protocol, takes away all the network stuff, which obviously makes my life a whole lot simpler. And what I've also done, for example, is restricted outgoing connections, and especially email, goes through a relay host so that the internal systems are not as easily identified. Because, for example, if you have an application that auto-scales out to a public provider, all of a sudden, I might be signing up for a marketing campaign and notice, oh, hey, look, first time the email came from this IP address on Amazon, second time it came from an IP address on this internal IP address that's maybe public or publicly reachable due to an error or something. And again, with auto-scaling, the security configuration has to be automated because you're going to be bringing up and down tens, hundreds, thousands of systems, maybe hourly. You can't have people doing that. But at the same time, you do need things like, you probably need to be able to log into the application so if something really weird happens, the guy can try and troubleshoot it. Because doing it without that is, well, it's impossible basically. Sorry? Yeah, it would be vulnerable to attack, and it would have to be secured. The same thing with software-defined networking. The same thing with CloudForms, right? If an attacker breaks into CloudForms, they now control your infrastructure. So, obviously, we have been aggressively auditing the source code. We fix security flaws very quickly. And of course, we're recommending that people deploy it, not public-facing. But the thing is, that's going to change. I mean, for a public provider that wants to use the product, they have to provide it publicly. Otherwise, they don't have customers. And so again, I think, well, and these are really hard problems because fundamentally, things like CloudForms, orchestration products, have to be able to manage the entire system. Right? Otherwise, that's what it does. So from the security point of view, there's the reactive side of fixing it when we find flaws. And from the proactive side, yeah, no, we're definitely looking at how can we harden this? How can we make it more robust? And I think longer term, I think one of the biggest things there will be the automated data collection and trending of usage. Because we're already seeing that in OpenShift Online, for example. Normal people don't do port scans. Normal people don't establish a million outgoing connections. You know, bad guys do that. Normal people don't call cron tab every 30 seconds, you know. So we're seeing these behaviors that sometimes can be detected at the application level, sometimes at the network level, you know, that indicate bad behavior, and that can be blocked. The OpenSSL thing, for example, you know, the one successful attack against Cloudflare on the low end required 100,000 packets. So, you know, you can imagine a firewall rule that says like, you know, after the 5,000th attempt at a connection that failed, maybe block them. And, you know, that would probably prevent a lot of the exposure of the truly sensitive data by dialing it back. Yeah, I mean, basically it's no different than what we went through with the web application thing, right? We went through this whole thing with web applications where all of a sudden, you know, you had a single machine or machines running a LAMP stack, you know, that were hugely vulnerable for a few years because PHP and all those guys were so bad at security, right? I mean, we learned, you know, and the good news is though, we know this in advance this time, so we're actually actively working on it in advance. I mean, so the good news is Red Hat has the security response team, which is about 20, I want to say 23, but we've hired a few people recently. And so we do reactive security. So that's like OpenSSL, bug fixing, responding to customer queries, that kind of stuff. About a year and a half ago, 2 years ago, they formed the product security team, and that's about a dozen guys, and they're doing the proactive side. So they're doing code audits. They're doing things like, you know, secure development. They're doing things like, you know, helping push, I think we announced it publicly. Yeah, we did. Secure temp in RHEL 7. So it's like essentially a poly instantiated temp directory so that, you know, even if your application is using /temp in a vulnerable manner, it's using like a private version of /temp. So it's not a problem anymore. So no, we're definitely trying to get ahead of the curve because, you know, with the internet, it basically took us like the better part of 10 years to secure it, right? Like it was really messy for a while. Like I remember when my bank went online and like I was like, no way am I using this because this is terrible. And with cloud, we don't have 10 years to fix it, right? We've got 1 or 2 years, and then we're going to be reinventing new stuff. So yeah, no, the biggest thing there is we are, like I said, we're trying to get ahead of the ball and being super fast on reactive fixes. Like we got the OpenSSL thing out in less than 24 hours. And it was supposed to be embargoed for a few days, so we were working with the expectation of we had until like Wednesday, all nice and calm, and then what happened is more than one person found it, so the OpenSSL group basically went, well, if 2 people found this in the space of a week, it's probably like, you know, more people know, and so it went public, and well, as you guys know, all hell broke loose. So does that answer your question? Yep. Yeah. Yeah. So the question is around security hardening practices. Honestly, I would say if you can, I would look at FedRAMP and the Cloud Security Line stuff because they contain a lot of good things. Like for example, using NTP to synchronize servers so the log files make sense. There's a lot of those little sort of hidden gotchas where when you read it, you're like, oh yeah, no, of course we should do that, or I think we did that, but maybe we'll double check that we did that. So my recommendation would be the Cloud Security Alliance has very readable standards. FedRAMP has relatively readable standards, but it's a bit more abstract in the sense of things like, you know, your software should be up to date. As far as hardening the system goes, OpenSCAP by default, the default content will lock the system down quite tightly. Well, sorry, SCAP won't lock down the system. SCAP will report the flaws and tell you what to do. A tool like Aqueduct will then actually allow you to lock down the system quite heavily. So I would recommend looking at Aqueduct and OpenSCAP as a good start because it's also automated and fast. I mean, I remember hardening systems 20 years ago where it was stuff like turning off XINetD and like that was magic, you know, and now it's like Red Hat Enterprise ships with OpenSSH enabled and that's it, you know, which 20 years ago would have been absolutely unimaginable. So I would say look to the automated tools and look to the policies like the CSA policies and the FedGov, the federal government policies. Some of them are not very, like NISPOM and some of the military stuff is really, I'm sure if you're a military guy, it probably is written in a way that makes sense to them, but I've tried reading them and it's just like, I don't get it sometimes. But the automated tools will harden them and show you what needs to be done. Yes?
Yeah, we went through a DICAP process and we used that OpenStack for like 90% of the job. But one question I have is we require you to security scan every quarter.
Yep.
They use a tool called Red Hat.
Oh yeah.
What happened is
Yeah.
kind of one, but
End of the world.
and we go to Red Hat and see, oh, you guys say it's low.
Yeah. Okay, so what happens there, because we see a lot of this, like especially the military, because one thing with the military we find is their definition of operational security is quite different. Like so a forward fire base, like they have very different operational security requirements than say like, you know, a bank IT. So what we found there is, so CVSS scoring first of all is very biased towards system security. So for example, you can have an application like CloudForms that's completely vulnerable to something horrible, and like the CVSS score is like 7, when it should be like, you know, 100, because it actually controls thousands of systems. So the CVSS scoring is somewhat suspect, and CVSS version 3 will hopefully address a lot of these problems. And then as far as what vendors rate problems as, so like we get this with Nessus all the time. You know, Nessus says this is terrible. You guys are saying like, don't worry, be happy. What's the deal? And so there it basically boils down to sometimes the vulnerabilities just aren't that bad on Red Hat. Yeah, they're terrible everywhere else, but on Red Hat, we disable it by default and we really recommend you don't enable that feature or something. Or there'll be a case of, you know, there's no trust boundary violation. So we've got a bunch of kernel denial of service attacks that require root level access to run. So we'll fix them eventually, but like not right away. Now, I guess for some people that could be a valid, oh my God, we really want this fixed soon. But like for the majority of Red Hat customers, it's like, no, root can shut down the system. You know, tell them not to do it. So like I said, one thing we do get is if you email in the query, you know, we'll definitely answer it. Yeah, oh, we see a lot of that. There's like 3 or 4 firms that like, yeah, I think they're in the same situation you are, where some outside auditor comes in and says, oh my God, your place is going to burn down tomorrow if you don't fix this. Yeah. Yeah. Well, and the worst is the banner scanning, right? Because we have old versions of software with backported security patches, and so Nessus freaks out and says, oh my God, you're running Apache 2.2 like something really old. It's the end of the world. And we're like, no, we fixed everything you're complaining about. So that can be the other thing that you might find. But yeah, feel free to email Red Hat support, and they'll be able to get it to the security team, and we can definitely, quite honestly, I've seen cases where a customer's brought something up and it's been like, ooh, we didn't think of that real world use scenario, and apparently it's quite common, so okay, we're gonna move up this fix a bit. So, because I mean, you know, the way people are using stuff keeps changing, and some people get, you know, what we thought was insane. Like, the fact that like OpenShift Online literally allows you to create an account with just an email address and then allows you to SSH into a host with like no payment, no personal data, nothing, just a working email address. You know, 5 years ago, I would have said, you're completely insane. You can't do that. I quit. And now it's like, no, that's a great business case. We're going to do that. We're going to give this away for free, and it's going to be secure and wonderful. Like, I outsourced all my SSL, right? I hope they're managing it correctly, you know, Cloudflare, because I have no control over it anymore. 10 years ago or 5 years ago, I would have been like, no way am I outsourcing my SSL. That's just crazy. And yeah, now people are doing it all the time. So, any more questions? Or, oh, yep.
So you said that you work closely with security and institutions, so you know what vulnerabilities are there and you can address them. How closely do you work with financial institutions that impose policies? And let's just say, just like for vulnerabilities, I like to see the next day after that says we have addressed the key because certain audit institutions ask for it, and we know that it affects homes of our customers.
So the question was basically how close do we work with customers, say in the financial industry, around vulnerabilities? That part I don't know. SRT doesn't have a huge amount of customer engagement because again, we're more reactive. So like where we typically get customers coming in is, I've seen a case where a customer came in and said, hey, look, we have this JBoss server, it's completely up to date and it's been compromised. Like you might want to take a look at this, you know, and see if it's something new. Turns out it was something else that they'd installed and forgotten about. So it's hard to answer that question. Like I know obviously we have a lot of financial customers that we work closely with. Specifically from the security point of view, I don't know because I don't really see that stuff. Like well, the incoming guys might see it, or it's handled more within the global support services a bit. And one thing is Red Hat is changing how it does support. We've actually recently been changing our process. So it's going to change quite a bit. So we now have this idea of what are called SBRs. And so essentially there'll be like a security group within GSS that will specifically handle the security stuff. And they'll have some specialized people there. And so I suspect our move towards that might address some of your concerns. But if you want to hit me up afterwards, maybe I can, I also know one or two people you maybe want to email that might be able to answer your question a bit better. So, thank you.